properties, process, path of the process. So all these terms are familiar with you, and many of you may be able to answer what these terms are, right? But still, to give a concise and precise definition or explanation to these terms, that is what I meant by this lecture. So straight away we will move on to the lecture. So this will be the overview of today's session. So first we will see what a system is, what do you mean by surroundings and boundary with respect to the system, and what are the different types of properties, and what do you mean by state, how do you define the state, and the process and path of the process. So system, suppose you take the room you are sitting as a system, right? So that could be considered as a system if you want to analyze the properties of that room. So for example, what is the dimension of the room, length, breadth and height, and how many occupants are there, what are the different objects in the system, in the room. So all these could be analyzed by considering that room as a system, right? So there are different types of system like closed system, open system and isolated system, depending on how the energy or matter is crossed the boundary of the system. We will see. So this is an arbitrary system, okay, and this surface, this cloudy surface, it's an arbitrary surface. There is really imaginary surface, right? So that is the called the boundary of the system. It is having zero thickness, does not have any thickness for the boundary. So boundary is the imaginary partition which separates the system from the surroundings. So whatever is there excluding the system are the surroundings. For example, consider your house. You are considering the room you are sitting as your systems. All other rooms in your house will be the surroundings to the system. Okay. So coming to the thermodynamics aspect, see high piston cylinder device. There is a piston rod and a cylinder. Okay. So this cylinder is filled with some fluid, some gas. Now the rigid surface or rigid wall of the cylinder could be considered as a fixed boundary. So boundary could be of two types, fixed or moving. So this fixed or rigid wall of the cylinder is considered as fixed boundary, but at the same time, depending on the expansion or compression of the gas, this piston could be moved down or up, downwards or upwards, the piston could be moved. So this is a moving boundary. The surface of the piston, there is a moving boundary. So now we are able to differentiate between a fixed boundary and a moving boundary. Clear? Now thermodynamic system could be classified depending on whether the mass is fixed or volume is fixed. Wise controlled mass system and controlled volume system. A controlled volume system is another name for an open system. So open system, we have classified system into three: open, closed and isolated. So open system, there could be transfer of matter or mass as well as energy either in the form of work or heat. W stands for work and Q stands for heat in thermodynamics. M stands for mass flow. So there could be mass flow as well as energy flow in the form of heat as well as work across the boundary of the system. This could be from the system to the surroundings or from the surroundings to the system. That is an open system. Your room again. Suppose the windows and doors are open. Anybody can come in and go out, right? So there is mass flow as well as energy flow. Any sound can be heard from outside to inside, isn't it? So that is an open system. Suppose you close all the windows and doors of your room and you are sitting inside the room. So no mouse can go out, right? Everything is closed. Nobody can go out or come in. Such a system is called a closed system. Only energy can be transferred to. So you can hear still the sound from outside unless and otherwise it is completely soundproof. The walls are still the electricity can cross the walls system boundary. So such a system is called the closed system. Now coming to the isolated system, suppose you cut off the electricity and you made the walls with some soundproof material, acoustic kind of material, and you are not able to see any energy interaction, what is happening outside, and no mass flow, no energy flow, either in the form of work or heat. Such a system is called an isolated system. We will see classical examples for these closed, open, and isolated. So let us consider a cup of hot coffee or tea kept on a table in a condenser. So when it is not closed, both heat and mass can cross the imaginary boundary of the cup. So such a system is called an open system. At the same time, when we close the top of the cup, no mass can cross the boundary. That is a closed system. Now the same tea or coffee can be kept in a thermoflask. So no energy transfer, no mass transfer when it is closed, as well as insulated. Such a system is called isolated system. I hope the concept of open, closed and isolated system is very clear from this classic example. Now coming to the second important term, property. Now the same room which you have considered as a system would be characterized by the dimensions of the room, the length, breadth and height, and how many occupants can be filled in the room, or how many objects are there inside the room, such as ceiling fan or switches, lights. So these characteristics by which the system is specified are termed as properties. There are two kinds of properties, intensive property and extensive property. Intensive properties are those which are independent of mass. Intensive, independent. Like we can learn, remember easily. Extensive are dependent on mass. So there is an easy method to differentiate between intensive and extensive properties if you are given with a group of bunch of properties. So this is a classical example. You consider a vessel or a container having a certain fluid having mass m, volume v, temperature T, pressure P and density ρ. Now assume that you are partitioning this container or vessel by an imaginary partition exactly at the middle, vertically. You are splitting the container into two. You are inserting a partition. Okay. So what will happen to mass and volume? It will become halves. Right? Mass as well as volume of the fluid or the substance contained inside the container will be exactly split into two. But what will happen to temperature, pressure and density? It will be the same. There won't be any difference, right? So the properties which were dependent on mass were mass and volume. When the property changes by introducing an imaginary partition, they are called extensive properties. The other properties which remain the same are called intensive properties. Clear? Yes. Now, when these properties have got specific values, we can say that the system is situated at a particular state. When these properties are assigned certain magnitudes or fixed values. For example, this piston cylinder device is having pressure of 1 kilopascal, volume of 1 meter cube and temperature of 25 degrees Celsius. The gas contained inside, the fluid contained inside the cylinder. So this gas is said to be situated at a particular state. When a force is applied on the piston, this property changes. So that is what we are going to see as a process. When one or more properties of a system changes from a state, that is called a process. And the intermediate stage the system passes through from initial and final system. The locus of such points is called the path of the process. So in the previous example of piston cylinder device, we have seen the pressure was 1 kilopascal. Suppose we are compressing the fluid by applying certain force on the piston. The pressure will increase, right? At the same time, the volume will decrease. So one property A and property B. Suppose this is volume and this is pressure. Okay, so pressure is increased from 1 to 2 and the volume is decreased from 1 to 2. Right? This will be the initial volume and this will be the final volume. So volume is